is mechanics. Mechanics. So the simplest definition for those of you who love to keep it simple is just to say it's the study of relationships among force, matter, and motion. So the key word there is motion. So simply, if someone asks you randomly, what is mechanics? And then you say, it's a branch of physics that looks at motion. You'll be correct. You'll be correct. So I love this classical definition of mechanics, which says, because we have classical mechanics and also have quantum mechanics. Quantum mechanics is a very Einsteinian. These things are that the likes of Albert Einstein try to analyze, especially when you're looking at something from atomic level. So that's reason in there. So that is quantum mechanics. But now in this case, we're looking at classical mechanics or just simply mechanics. So it concerns the motion of objects that are large relative to atoms and move at speeds. So saying, who is that? Guys, who is that? So saying classical mechanics is motion, it concerns motion of objects that are large relative to atoms and move at speeds slower than the speed of light. So anything that is relatively big, because if you hear relatively large, some of the words like relative, some of you are afraid. So anything that is bigger than the atom and it's moving at a speed you can observe, the motion we actually observe ourselves, not Iliam Man and Matthew Miyama X-Men, but the motion that we observe ourselves, like e.g., you're able to see the car moving, you're able to see yourself moving, you're able to see a stone moving on its throne. All that is mechanics. So simply, mechanics is the study of motion of objects at observable speeds, at speeds that we can observe. So mechanics has two branches. Mechanics has two branches. There's kinematics and there's also a dynamics. So kinematics is what you're doing at grade 12 when you said a car starts from rest and accelerates uniformly in time t to a final velocity that, find the acceleration. That is kinematics. Why is that kinematics? You describe motion without relating to the forces that cause the motion. So the study of motion without looking at its causes is kinematics. Dynamics is the part of mechanics where you look at the motion and relate it to the force that causes it. E.g., when you said F net equals MA, that one was dynamics. When you relate force to motion, then what you get there is dynamics. So now these are the things. I've looked at this screen because that's the one that I've put on the study master. So try to analyze it from that perspective. So if you look at the things we've mentioned, mechanics, when you start mechanics, you simply now start applying those vectors, the important vectors that we've talked about, e.g., velocity, displacement, acceleration. So now these ones become more useful here. So those quantities, this is where you use them. You use them when you are studying mechanics. You use velocity, acceleration, those vectors that we're looking at. the velocity, the acceleration, and the displacement. You analyze them when you're looking at mechanics. Are there any questions, guys? Are there any questions? No, I don't want to threaten you, but
I have a question.
yeah?
I have a question, sir.
Yes.
I just didn't get how you said the kinetic mechanics, but I wanted to repeat the definition because I didn't get it clear.
I can't get you, Sam. Put your mic properly and then tell me again. You didn't get what? Robert, you didn't get what?
I didn't get the way you actually. I didn't get the way you define kinetics.
Or kinematics.
The first branch of mechanics. Kinematics.
Oh,
Yeah.
I was saying
I didn't get what
kinematics.
you said. I would love if you.
I want to explain, Kai. So I was saying kinematics is motion without looking at the cause. So if you just look at what you are doing in grade 12 to say a body starts from rest and accelerates uniformly to a final velocity this, in this time find the acceleration. There you haven't mentioned any force, but you are talking about a body moving. But for a body to move, there should be a force applied. So when you look at motion without relating to the force, then that is kinematics. Are we together? Robert, are we clear?
Very clear.
Yes.
Okay.
Yes, I'm clear on that.
All right. Then dynamics is the opposite. You relate motion to the forces. Helen, your mic is on. Your mic is on. Helen Namusamba. Your mic is on. So those are the things. So mechanics is simply, are there any other questions? So mechanics is simply a branch of physics. There are so many other branches. I listed them as other branches and I said at number 2, there's relativity, thermodynamics, electromagnetism, optics, and quantum mechanics. Those are the major branches that are there. So relativity, you look at movement of objects at any speeds, especially the speed of light, like those ones in X-Men, those fictitious speeds. So those are the things. So that's relativity. Thermodynamics, everywhere where there's heat, work, temperature. Remember those things, eh? Systems. So when you're looking at thermometers, engines, all those, that's in thermodynamics. Then there's electromagnetism, magnets, transformers, and electricity. I'm sure you've seen a transformer somewhere. So all those you look at them in electromagnetism. Then there's optics. Optics is where you study the behavior of light and its interaction with matter, reflection, refraction, and all those. Then there's quantum mechanics, which we said is modern physics, theories on the behavior of matter at submicroscopic level to macroscopic level. So the quantum mechanics will look at the behavior of, say, electrons, and then you generalize to the behavior of other things. So those are the things that are there. You are not expected to study these branches, just supposed to know them, that they are this. At this point, your interest is just to know what is mechanics. Okay? So now, what we look at everything and simplify. So there's translational motion. Someone will asked what's the difference with the translatory. Those are interchangeably used, they are the same. So translational motion is motion by which a body shifts from one point in space to another. That's easy now. To move something from one point to another, to move your relish, your piece of meat, from your pot to the plate. It has moved from one point to another. To move from a station to the college, something has moved from one point to another. For a vehicle to move from one point to another, like there should be movement. That's what you say. Even painter, that's what you say to say. A life, when you are praying, like there should be movement, because you're like there should be movement. You feel wasela. Not waingira mu church ulatukana but uchirule ulatukana no. Like something should have changed about you. So translational motion simply means motion where something moves. Why? Because there's a comparison between translational motion and rotational motion. Because in rotational motion, something can be rotating about an axis, but it doesn't actually change its location from one point to another, because it's moving about a rigid point. So now, translational motion, the one that we are interested in, is the linear motion. So that's on the notes also. I've shared my screen. Can you see the screen, guys?
Yes, sir.
You can see the screen there?
So we can see it.
Because
Yes, I can.
paliwo pointere padimu
I can.
nkalayi berengerafi paliwo pointere padimu so kutila no I'll be reading nza iberengera cha banana nda mike munashimyama mike so atinga ole ponta kule wemwe ole pontera mu muchibota then ole ponta mike na yaka me I can take it. You want me to hear that statement, that complaint? It's not my fault that there's COVID. It's not my fault that we are learning this way, but I'm trying my best. I'm sure you can see. So those are things. So now, the one that we're interested in is rectilinear motion, which is motion along a straight line, or simply linear motion. Kainga tualanda sana utuma bomba towards rectilinear motion. Some of you get scared. Yeah, we say in rectilinear motion. So that's the way it is. So now we want to move to some terms, that is average velocity, displacement, in fact, displacement, average velocity, and instantaneous velocity. So those are the ones that we want to look at. So how do we look at them? So we are considering this thing, a fuel dragster, as it moves in the positive x direction. It moves from an initial position x1 to a final point x2. So this one is moving in the positive x direction. So to move in the positive x direction is to move to your right. So the origin, the start is the origin on the Cartesian plane. So you must understand the Cartesian plane. So if something is moving to the right, then that's positive. If it's moving up, then that's positive as well. If it's moving down, that's negative. If it's moving to the left, that's also negative. So now, if something is moving here, this vehicle, it's very fast, I'm sure. The AFU or dragster, it's moving very fast. So it's moving in the positive x direction. Then they tell us that it will pass a point x1, which is the initial, to a point x. The displacement, guys, is simply the change in the position. So the displacement we denote it as delta x. Those of you who want, you can still maintain s. It still has the same relevance. It's still the same thing that you used to do at grade 12. But then my texts have delta x. So if I started wanting just x, s, it means I have to edit a lot. So now, if you look at this, guys, delta x is equal to the final minus the initial, x2 minus x1. So you can see that. So when you just subtract the final minus the initial, what you get is the displacement. Then now we move in to define the average velocity. The average velocity is the change in position. Remember, change in position is displacement. So average velocity is simply total displacement divided by the time interval. Change in position divided by time interval. Sometimes you can zero the starting time to say, apayamba munani, when you zero your stopwatch, then everything you get as the motion is going on is your time interval. But now for this dragster, it's moving. When it moves from a point x1, which is 19 meters, at time t1 equals 1 second. Then it moves after 4 seconds. Its a position now, which is the final, is 277 meters. So the displacement is simply 277 minus 19. It's here in our notes. So it is 258. So to get the average velocity, you get the displacement, which is 258, divided by the time interval, which is t2, which is 4 minus 1, t2 minus t1, which is 3. Then to get the average velocity, you divide the change in position, which is the displacement, the 258, over the time, and you get the 86 meters per second. So average velocity is defined as the displacement divided by the time interval. So you must capture that. Then one of the points is physics. We'll continue to emphasize that. In most cases, we'll just be saying find the final speed, find the speed, find the speed. And yet speed is a scalar. We'll use speed and velocity interchangeably. It's erroneous, yes, because speed is a scalar. But in almost all cases where you'll be asked to find the speed, it will be the velocity that will be asked of you. But the difference, you must know it. Speed is distance over time. So average speed is total distance over total time, over the time interval. While average velocity is total displacement over the time interval. Then the last point to emphasize in this is the instantaneous speed or the instantaneous velocity. The instantaneous velocity is the velocity that you see on your speedometer. That which you see on the speedometer. Why? Because it's the actual speed of the vehicle at that point. Nishi limbomu wachanda pa 20 karod kabas muta chachimbutu sheko. That speed is the instantaneous, the one that you have at a particular point. So that's a definition for instantaneous from the word instant. So because it says velocity at any specific instant of time or specific point along the path is called the instantaneous velocity. To get the instantaneous velocity, guys, you have to differentiate. Did you do differentiation in grade 12? Guys, calculus introductory.
Yes, sir.
Yeah.
I'm a best.
Yes, sir. We didn't do some of us. Yes, sir.
No, it's in the syllabus now. From 2016 up to now, it's in the grade 12 syllabus. So you must have ideas now. So you differentiate. Differentiation was the one we called dy dx. But to get speed, we do dx dt. Meaning the horizontal axis, most of the times in our mechanics, the horizontal axis will mostly be time. Why? Because time is the independent variable against which we compare a lot of things. So it's very important. Time is very important. But mostly, the most important to physics is energy. You learn physics for you to tap energy. So that's the reason why, because in physics you find bulbs, transformers, all those are about energy. Engines, all those are about energy. So in most cases, it's about energy. So energy and work, those are the most important topics. So those are things. So the velocity at any specific instant of time or specific point along the path is called the instantaneous velocity. To get the instantaneous velocity, we differentiate the position function. So instantaneous velocity, in short, is the derivative of x with respect to time. The derivative of x with respect to time. So how do we get this? We should always be given an equation, then we differentiate it. So you can't get an instantaneous velocity without knowing the function. The function is a simple equation that you have that relates a variable to another to time. So now you must be given that for you to find instantaneous velocity. So those are the cases. There is a question. I'll put the answers on the start master after some time, but I want you to try it. So we have cheetah, like that's in breeding. Ili mumpanga ile fokulya. So it's crouching in ambush 20 meters east of the observer, as shown in this figure that is here. At time t equals 0, the cheetah aliyebutuka 50 meters east of the observer. Now butuka. Then the cheetah runs along the straight line, balondora. During the first 2 seconds, the cheetah's coordinates vary with time according to the equation, Hilbert Pera equation. X equals 20 plus 5t squared. A, taparika A hapa, mwalamu bikeko. Find the displacement of the cheetah during the time interval 1 second and 2 seconds. B, find the average velocity during this time interval. So you find, first of all, displacement, then you find the average velocity. Then the last one is to find the instantaneous velocity at t is equal to 1 second. So those are the things that you do. So to find displacement, you will simply find x1 and x2. How will you get those ones? You get e1 second to get x1. So x1 is the position when time is t1. So wala bula kaka 1, ukase substitute apa di 5, apa di t. So you say 20 plus 5, open brackets, you put 1 squared equals, you get your answer. Then again, x2, you say 20 plus 5, open brackets, 2. You make sure you put in brackets, squared, you get your answer. To get a displacement, you do x2 minus x1. That's how you work it out. Then, to get the average velocity, you get x2 and x1, or whatever displacement you have in A. Then you divide over t2 minus t1, which is 2 minus 1, which is simply 1. So whatever answer you get there, you divide over 1. So the only difference between A and B will be the units. Whatever answer you'll be getting numerically should be the same because you're dividing 1. Then the tough part is to get the instantaneous velocity at time 1 second, which is very nice. So there you differentiate this one, you do dx dt of 20 plus 5t squared. Whatever answer you get, you remember the derivative of the 20 is 0 because it's a constant. Go to differentiate constant, it's 0. Plus 5, then the 2 will come in front there, then 2 minus 1. So possibly you may get maybe, I don't know how you work it out, you get maybe 10t. Then you substitute where there's t, you substitute 1. Then you get your answer. I was rushing in this because I want to give you time to express yourselves. But I'm still disappointed at someone saying, I'm still disappointed. Tatulaishwana na sana guys, shami vundura po ine, shai sabo mgumi kadipira. Ifo muste mundu ngawa sana best, mambo kumwebela mudi maigo kutila. Tizai belengera fwebe, ndapado fwari elondora. Guys, yonse ukulondora ndelondora shwo. Imo. Crispin.
I think you know the person who landed the coffee later. But anyway, just forgive us. Some no,
it's fine. Therefore, we your question, Kadif.
So, sir, my question is on the same thing, differentiating. You're going to explain a little bit, at least we get an idea from your explanation, then maybe we'll be able to work ourselves through the differentiation that was in calculus. In some of us, we didn't do it, but we should be able to get the point here.
The beauty is that in this very group, there's someone who was very generous and gave books. Remember, one of the books he gave you was Pure and Applied. That's Pure and Applied. Go and read it. Just talking on top of face, just introduction to differentiation. That's all. Then I'll put some notes on differentiation. I'll put something that can guide rules for differentiating, because we only differentiate polynomials here. We don't go kuri further idea kwa number exponents. No, we don't do implicit differentiation. No, we only do polynomials, which is the x to the power 4, x to the power 4 or t to the power 4. You remember the 4 should become a coefficient. Like if there's a 2 here, the 2 goes in front and multiplies the 5. Then you say 2 minus 1. So that's the reason in there. So please try to analyze from that perspective. Stephen.
Sir.
Yes. Welcome, Mike.
Sir, what about
Yes.
Yes, I'm saying what about the Instantaneous Velocity?
I can't get you, sir. Kelvin, you're making noise. Kelvin, you're making noise. Stephen is on the floor. Yes, Stephen.
Yes, sir. This derivation for Instantaneous Velocity, it says is the ambient velocity the rate of time interval operation is 0. And the velocity is given by t that's r on top, then limit then delta x over t, then again there is a change in t as t approaches 0. So now where does it like 0 come from? Like according to the example here, 0%.
No, when you differentiate a constant like 20 or 4, anything that doesn't have a t, it becomes 0. The derivative, the derivative of a constant is always 0. Anything that variable t. So you just have to master. Even if it was 1,000 or 4,000, the derivative of the number that is not a coefficient of t is always 0. So remember those rules. So it's not like where does a 0 come from. Yes, someone saying. So when you differentiate 20, you get 0 ultimately. Then the 5 as a t, then you differentiate it the way you differentiate polynomials. That's why I've said go and Google a bit on how to differentiate polynomials. So when we talk about it next time, you have a guide. So the 2 always comes and becomes a coefficient and multiplies by the 5. So you get 10 t to the power, it should always be n minus 1. So upper the n is 2. So it will be 10 t to the power 2 minus 1, which will be 2 minus 1 is 1. So that's the reason why you get 10t only. Guys, I'm running in 5 minutes. Anything that you can sneak in? I've said already that I'll send the answers for these things, but I don't want to shove your feed you to the point that question ilefika number answers na ikwata. No. I'll make sure I'll make sure we understand the concepts first. So therefore mupitemo. I don't want you to get it correct the first time. It's the first time you're knowing these things. Try to go through. Then when you understand whatever, I'll send the answers. I'm going to put them, nobody in a coffee. Don't download them fast. First go through on your own. Then you Stephen, ni kwesa mundi kukwafita man tata. Kala ya mubiri na idingana no rubuto rudimu. Tata wa Stephen. Oh, Naimon. You have shared. Share even with our friends. Let's share it on WhatsApp. Now, Kwatama, Ama notes. I've seen what you are showing me, sir. Share it. Whatever it is that we are doing, we've simplified all those concepts. The topic of limits. Imagine boy to aleta limits, your friends would struggle a lot.
Okay, sir. All right.
Anyone else did it? Or Stephen was showing us the book he is reading from, why the definitions, mine and his are conflicting a bit. So I've told him that whatever I'm giving you is a simplified version of whatever it is.